Good morning. Happy Monday. Today I wanted to do an unboxing, and very exciting actually today, because those of you in AP Calc and even those of you in my pre-calc classes, you know, every year we do design an AP Calc shirt, and this year's shirts have finally arrived. I haven't opened the box, so I thought we'd do this together. Okay. I'll use my Klingon Batleth letter opener. Let's dig in here. Okay, I've been very impressed by my experience here ordering these shirts. Very exciting. And let's just open this up here. A lot of plastic packaging, that's a good sign. All right, this packing slip. And I'll have to count the sizes, make sure everything's right here later on, but here are the shirts. Still can't believe this was the design that we went with, but all right, so Booth Dog, yours truly. And on the back, we have our AFHS AP Calc A, B, and BC for this year. Okay. It's exciting. I'm excited to finally have them. All right, my second AP Calc shirt. All right, so I'll have more information for those of you who ordered a shirt on when you can pick those up. Just hold on to that, and let's jump into our lesson. All right, happy Monday. We have just a couple of weeks left, so let's get right to it. You do have an exit ticket due by midnight tonight. I'll explain what that exit ticket will look like a little later on. But really, this week is going to be strictly review and making sure that you're as successful as possible on that culminating activity. Speaking of which, your culminating activity for seniors is due this Friday by 11:59 p.m. Juniors, you have until next Friday at 11:59 p.m. to submit that culminating activity. Additionally, seniors, all your retakes must be completed by this Friday. Email me if you need to set up an appointment or use that link that I have sent out a couple of times now on Google Classroom to make an appointment for this Flex Wednesday. Okay, so let's jump right in. Again, we're done with content for the year. So here's our list of the many units, the many different concepts and ideas that we studied over the course of the year. And really, each day this week, I want to go through a few of those units, and I'll hit the most important pieces, at least in my opinion, from each unit, as well as those key concepts that you'll need for your culminating activity. So hopefully this works out any misconceptions or misunderstandings you might have as you're working on your culminating activity. So Unit 1, this was all about basic functions. Key things to remember here. Domain. Remember that domain, we have to check for a few things. Okay. Domain. Denominator of any fraction cannot equal 0. If we have a square root or an even root, the inside of an even root can't be negative, so it has to be greater than or equal to 0. And finally, if we have any kind of a log, the inside of any log can't be negative and it can't be 0. So the inside of any log has to be greater than 0. So that's when we're looking for domain. For the range, really we're graphing it, we're looking at all the possible y values, the outputs of our function. Remember that when we're writing this with our interval notation, okay, parentheses mean we are not including. Brackets, we are including, so they're inclusive. So if I want to include a value, say our domain is 0 to 2, this means that we are including the values of 0 and 2. This means we're including every value between 0 and 2. And of course, anytime we're using infinity, we make sure to use parentheses since we can't really equal infinity. So we use that notation for our domain, for our range, and for talking about increasing and decreasing intervals. Remember, increasing just means as we go from left to right on our graph, is the function going up, then it's increasing. If it's going down, then it's decreasing.
And then talking about max and min values. So what's the highest possible point on our graph? What's the lowest possible point on our graph? We also talked about average rate of change, AROC, average rate of change. It's a very important concept for those of you moving on to calculus. Remember, average rate of change was basically just the slope between 2 points. And we all know the formula for slope, it's rise over run. The form that I use most will be most helpful to you moving on to calculus. If we're going from one point to another, so the point A, f of A, to the point B, f of B, then this becomes our slope formula, our average rate of change. So that's an important formula to note. Transformations. Okay, remember that, let's say we have f of b times x plus c plus d. Anything that is outside of this function itself is a vertical transformation, since it's affecting our output, the y value, and we just do what it says. If we're multiplying, that's a vertical stretch or compression by a factor of whatever that number is, okay? And if we're adding out here, then that's a vertical shift up. If it's subtracting a number out here, then that's a vertical shift down. If we have a negative in front of the whole thing, okay, then that is a reflection across the x-axis. Looking at the inside of this function, you can see we are directly changing our input value, our x value, so this is a horizontal transformation. And we do the opposite because we can think of x as kind of compensating for whatever's going on here. So this b right here is a horizontal stretch or compression. Again, remember, it's the opposite. If it's negative, then that's a reflection across the y-axis. And then this c value, that is a horizontal shift. If it's plus a number in there, then that is a shift to the left. Remember, it's opposite. If it's minus a number in there, then that's a shift to the right. Composing functions, this is where we had functions that look like this. We have a function in a function. This is very straightforward, really. Say we have f of x equals x plus 1 and g of x equals x squared. If I ask you for f of g of 2, we need to find g of 2 first. So g of 2 equals, we're going to plug in 2 here. And then we plug this value in for g of 2. So now we're looking for f of 4. So now we plug that in to our f function, and we get 5. Okay. And then, of course, inverse functions, this is where we have our special notation, like that. Okay, that's the opposite of a function. We are undoing our function. So inverse functions switch our domain and range. They switch our inputs and outputs. How do we find an inverse function? Switch x and y, solve for y again. We're, again, just changing our inputs and outputs. So your first question on your culminating activity is all about Unit 1. So hopefully this gave you a nice review of the skills that you'll need for those questions. I know I went quickly. It's because I don't want to sit here for 30 minutes and make you watch a 30-minute video. So go back through any pieces that you missed that you want to hear again. And then, of course, reach out to me if you need any clarification. I'm not going to give you a ton of help on the culminating activity, but, you know, I also want to reward you for watching this video. So thank you if you have been consistently watching, tuning into these lessons. I'll be a little more willing to work with you if you mention that you saw this video. All right, number 2 on your culminating activity covers Units 2A and 2B. Remember, we split that up into 2 halves. The first half, 2A, talked about polynomials. So the first key skill you should know from this unit, synthetic division. Okay, so remember that is if we're dividing by a binomial, so by a first-degree polynomial, and we take the opposite, we take the actual 0 from that binomial, and then it's just the coefficients. Okay, so I guess I can quickly do an example. If we have x squared minus x plus 1 divided by x plus 4, our 0 would be -4. We list our coefficients, drop the first one, multiply, -4 times 1 is -4, add, multiply, add. So our answer is x minus 5 with a remainder of 21. Okay, Okay, so we could write that like, excuse me, like this, okay? X squared minus x plus, I'm sorry. Okay, and really synthetic division is just an important skill for us to use as we continue looking for, specifically in this unit, graphs. So finding all the zeros of a polynomial, it was a very important thing that we did. Of course, we have all of our factoring skills. We can graph it and look at the zeros. And we can use, if we recall, the rational zeros theorem. Remember, this is where we have P is integer factors of the constant term, Q, the integer factors of the leading coefficient, and then we put P over Q, and this becomes our list of possible factors, possible rational factors of our polynomial. And then we use synthetic division, we start testing them, okay? And then our hope is that we find one, we've divided, and we divide until we get down to a quadratic, and then from there we can solve a quadratic and find its zeros using factoring, graphing, or the quadratic formula. Okay, so this is a key skill. Okay, it's something you might need to use in number 2. End behavior, remember this is both up, both down, rising, or falling. So if we have a polynomial and it has a positive leading coefficient and it's an even degree, think of x squared. Okay, so both up. If we have an even degree and a negative leading coefficient, okay, negative x squared, we know that's opening downward, so both down. If we have a positive leading coefficient and an odd degree, we say that this function is a rising function. From the left to the right, it's going up. And then negative, odd degree, falling. From the left to the right, it's going down. So these are the only 4 possible end behaviors of a polynomial graph. Putting that together with our zeros, we're able to sketch the graph of a polynomial. Okay, so we find our list of zeros. That's, of course, where we're hitting the x-axis. We know its end behavior. And then we look at the multiplicity of each zero. Remember, that's the number of times a zero appears. If our multiplicity is odd, we are crossing at that zero. If it's even, we are bouncing off the x-axis at that zero. Okay, and taking all that together, we're able to sketch the graph of a polynomial. That was a lot. But for number 2, first couple, or at least the first part of that question, where you're sketching the graph of that 3rd degree polynomial, you're basically following that process. Identify the end behavior, find all the zeros, using like the rational zeros theorem, kind of guess and check to an extent, and then sketch the graph using multiplicity. For parts B and C of number 2, okay, in part B, we're simplifying a rational expression. So very similarly, we're going to factor it. Maybe that requires the rational zeros theorem. Maybe you just want to graph it and see what the zeros are, so that tells you how to factor it. That's fine. Okay, we're dividing. That means multiplying by the reciprocal. Factor everything, cancel everything that cancels, and then see what we're left with. Anywhere that we cancel, we have a hole in our graph. Okay. After we cancel, after we simplify, we have vertical asymptotes wherever the denominator equals 0. We have horizontal asymptotes or slant asymptotes depending on whether the function is top-heavy, bottom-heavy, equal. So this is something we've talked about very recently when we're looking at limits involving infinity. So shouldn't be too bad for you since we've just looked at it again. But to recap, top-heavy function, the degree of the numerator is bigger than the degree of the denominator. That means there's a slant asymptote. As x gets really big, as we take the limit as x approaches infinity, then our function just keeps growing. So to see exactly what we're approaching, we just divide that function and see what function we end up with. If the degrees are equal, then we have a horizontal asymptote where y equals divide the 2 leading coefficients. Okay? It's because as x gets really big, as the limit as x approaches infinity, everything else cancels out except those leading coefficients. And then finally, if it's a bottom-heavy function, the degree of the denominator is larger than the degree of the numerator. As x approaches infinity, that whole fraction is getting smaller and smaller and smaller, which means we're approaching 0. taken as a whole, we find our zeros or we find our asymptotes, we find maybe our x and y intercepts. That allows us to sketch the graph of our rational function. Okay. So that's the rest of number 2. Look back at your old tests, look back at your old notes for more examples, and of course, let me know if you need any further assistance. Finally, Unit 3, exponential and log functions. Okay, key things to remember here, converting between log and exponential form. If I have this exponential expression, a to the y power equals x, and I want to change this to a log expression, log base a of x equals y. So these are equivalent statements. One is in exponential form, one is in logarithmic form, but they're telling us the same thing. A to the y power equals x. Okay, so being able to convert, expanding and condensing logs. So if I have a complicated log, maybe log, I don't know, m squared times n over x. When we are dividing inside a log, we can split this up over subtraction. If I'm multiplying, I can split that up over addition. And any exponents inside a log, I can move and turn into a coefficient of the log. Only thing we have to remember is that all the logs have to have the same base. Okay. So that's expanding, or we can go backwards to condense a log. Another important skill. Solving exponential and log equations. Okay, so this really comes into play when we're looking at those word problems. We have exponential growth or decay, and of course our interest problems. Number 3 on your culminating activity is all about Unit 3, exponentials and logs. Remember this formula, PERT, okay? You might see it look a little different, especially if we're not talking about interest. We don't usually call it the principal. We would call it the initial amount. We use A0. But regardless, those are the same thing. So remember, we're always using this. So for part A, for part B, for part C, we're using this expression, plugging in everything that we know. Sometimes you're solving for R, sometimes you're solving for time. Okay. Remember that anytime we're dealing with decay, this R value is negative. It's a negative growth rate since it's getting smaller. That should help you with number 3. Okay. It's as far as I want to go today. Tomorrow we'll look at Unit 4, 5, and 6, trig. Your exit ticket today asks you to submit any questions you might have from the culminating activity or just in general related to the units we just discussed. Okay, so units 1, 2A, 2B, and 3. As always, reach out to me, join our Google Meet if you have any questions, if you need more immediate help. That exit ticket's due by midnight tonight, retakes by this Friday, and your culminating activity this Friday. Of course, I'm talking to seniors, juniors, you have an extra week. Okay. All right. Have a good one.
All right, well, that was today's lesson. Make sure you're finishing up that culminating activity over the next few days. Let me know if you need anything at all. We're almost done. Okay, let's get to the end together. Have a good one.